Alright, so we're doing number 10 here. Oh, wait a minute, I need to get one other thing open. Alright, so number 10. I'm not going to do part A, you can do part A. Part B. Yeah, according to the ship's clock and calendars, how much time elapsed on Earth in the 1-year trip? And then, okay, so this one is asking us about time. So for the Y, I'm going to focus in about time. So let's see. Time is based on your frame of reference. The faster you travel, the less time passes for you as measured by a stationary observer. Time is based on your frame of reference. Let's see, anything else? So maybe I'll put while traveling to age less. Something here. Yeah, I think that would do it for a good Y. Yeah. Oh, we should probably throw that good old catchphrase in there. Speed of light is constant. All frames of reference. Any questions on that for those of you that are paying attention? Excellent. All right. So in approaching it with your how, because you're interested in time, I would strongly suggest using your time equation. That'll be a good thing. And then since you're going between different frames of reference, you'll also want your good old friend the Lorentz transformation. All right. Keep in mind that delta t is always greater than delta t naught, since gamma is always greater than 1, right? Because we did that last time when we were going over the example problems. And from that, I'm going to keep in mind that, and for my y, that the time on the ship is going to be less than the time that passes on Earth, right? Because the ship is traveling, and so less time is passing on the ship than passes on the Earth. So when I'm doing part B here, I'm looking for an Earth time that's greater than 1 year. For part B. So I might even think about that. For part B, my answer should be greater than 1. I use YR for year. They use just Y. I think it's clearer. So it should be greater than 1 year. And then for part C, well, that one I would suggest kind of using your own logic. I mean, if you're 27 years old, probably you guys can figure out how old you'd be a year later. I'll leave that up to you. And then you want to figure out how much your sister aged by how much time passed on Earth. So, all right. So that's my suggestions there on the how. All right. Give it a try. Let me know if you have questions or when you're ready to move on to the next part. Remember, we're avoiding that just plug in your own numbers, but actually having you try it. So I'll make sure my numbers work for me, while you making sure your numbers work for you. And if you need help, that's what I'm here for. And when the class is ready, we can go on to number 6. We can even go on to number 6 right now. So for example, like my gamma, when I substitute it in, I have 1 over square root of 1 minus 0.99c squared over c squared. If I do a little bit of algebra there, I get 1 minus 0.99 squared times c squared over c squared. Right, because that squared refers to both things, and then those c's cancel out. So that's what I did. Sorry, say that again? No. I would need to do the rest of the math there. Don't forget that 0.99 is squared, and you've got that negative, the 1 minus that quantity, and then you have the square root. Yeah, careful, don't skip the math stuff that's written down there. All right, number 6. Meter seconds passing a spaceship has a length of 0.96 millimeters. What's the speed of the spaceship? Trust your answer in terms of the speed of light of c. All right. So I'm going to start off with the idea that length, mentioned in direction of travel, is based on your frame of reference. The faster something moves, the less length it has. And then our good old speed of light is constant in all frames of reference. Yay! Agree? Disagree? Did I miss anything? I think I got it all. You agree? All right, let's go down that good old how then, as long as everyone agrees. So, this problem has to do with length. So I know it might be shocking, but I'm going to, oh, nice, I already have that.
We're doing the same equation.
Well, last time the problem dealt with time, right?
Yeah.
This time it deals with length. So I'm just going to use the length equation. Yeah, T time L length. But my Lorentz transformation is still there, right?
What does L small mean?
Oh, that's a good question. So, what do we know? We know gamma is always greater than 1, right? That means L compared to L naught. If you divide a number by a number greater than 1, do you get a bigger or a smaller number?
Smaller.
Well, let's try it. Let's take 5 and divide it by 2. Smaller number. So that means L is always less than L naught. So which length is less? The one in your frame of reference or the one in the moving frame of reference? The moving. You're doing so well then. So L is always the one that you see moving. And L naught is in your frame of reference, or when the thing is not moving. So, in this problem, this would be the Earth, and this would be the ship. And so they tell us, let's see, what facts do they give us? They tell us a meter stick. What does that tell us? In its frame of reference, it's a meter long. Wasn't that clever?
I just realized that, but it's so annoying.
And they want our answer in terms of the speed of light. Now, how I think about that, notice it says V equals some number times C. So one way to think of that, if I have a number that says V equals something times C, I could do a little algebra. And if I group V over C, I can just get that coefficient. So sometimes when I think of gamma here, I do a little grouping in my mind. And I put V over C inside the parentheses. You see what I did there? That little grouping? Now, I can solve for V over C, and I'll get the coefficient I want, rather than solving for V and then having to go back in terms of C and all of that, all that nonsense. And again, I avoid using a number for C, which makes my life easier. Okay? So in this one, we're looking, think about it as you're looking for V over C. You know that L from the ship So they give us that, right? 0.960 for me. And from the Earth, oh, wait a minute. Nope, I want to swap those two. This one's the ship, sorry. And that one's as measured from the Earth. I forgot which way we were looking. And I know on the ship it's 1.00 meters. It's all for V over C.
Where are you plugging in?
I'm using the length equation there. L equals L naught over gamma.
So we, what?
So you do your algebra. I can help you with the algebra when you get stuck, or try the algebra. What type of number are you expecting? Are you expecting a number, a big number, a little number, less than 1, greater than 1, negative? Less than 1. You want a number less than 1. Because if you had 1, it would mean it was moving at the speed of light. Greater than 1, faster than the speed of light, which we know is not possible.
How would I do?
So let me just